Cool. Hey, we're live. Awesome. Hello. My name is Adam. I'm coming to you from beautiful Victoria, BC, where it is cold and snowy. Uh, and I am doing my daily stream about making a Game Boy game in assembly language. This. Whoop, whoop. This here is my cat. Her name is Nellie. She's going to be joining me for at least part of the stream, apparently. I'm going to be a little distracted petting her. Hopefully that's okay with you. So let me just catch up on where we are. We kind of have like the basics of the game here and working. We got a title screen. We got a ball that bounces around. Yesterday, I devoted a long and painful stream to try to get the ball to speed up a little bit when it bounces off of things. And I did finally, at the end, get it working, but boy, it sucked. It was not a good stream. And that is, unfortunately, partially due to my own incompetence, and partially because the ball velocity is 16 bits, and trying to do any kind of fancy signed 16-bit arithmetic on the Game Boy is always a recipe for frustration on account of the fact that the Game Boy has a very, very limited 8-bit processor. It is real bad at doing things like 16-bit signed arithmetic. Hell, even 16-bit unsigned arithmetic. Hell, even 8-bit signed and unsigned arithmetic it's not super great at. That's the fun of it. So it was pretty unpleasant, but I did finally get it working. And yesterday I left things off with this sort of question of, did I actually get things working? And I'm pretty sure I did. The thing in particular I was concerned about was this here, where in the negative case, I realized at some point that I was trying to use 8-bit math to do a 16-bit thing. Because really what I'm doing here is I'm trying to add, the 16-bit number for minus 20 is going to be like FF something. I don't know off the top of my head what it is. I did yesterday. FFF0, possibly. Let's find out just for the heck of it. So we're going to go into Word mode, and I'm going to do minus 20. FFE0, sorry. Hey, Nelly? Oh, well, I guess you can look at that. That's fine. And I was just trying to do this with a single 8-bit operation, and then do a whoop. Okay. She doesn't do anything fun when she's on camera. She must know somehow. But she's like very interested in this rubber band. Was batting at it violently. Which normally would have been fine, but she was doing it while on my desk, which is less fine. Yeah? You want to go get your rubber band? Yeah, there we go. Okay. So I was trying to basically add this 16-bit number, doing like a single 8-bit addition plus decrement. And I was like, is that okay? And I realized that is okay, because if you think about it, if we wanted to do the full 16-bit version, what we do here is if there was a carry, like the 16-bit version is to say, if there's no carry, then we're done. Then if there's a carry, sorry, you add, sorry, you're not done. If there's a carry, you would jump to like a no carry. You would increment it, and then in the no carry part, no, you would add FF. Like this is the correct 16-bit version of it. And I realized that these two things are actually equivalent, because what happens here is that if there's a carry, you end up decrementing the second byte. What happens here is if there's a carry, you end up incrementing the second byte. Oh, sorry. Let's get this straight. Here, if there is a carry, you increment the second byte, and then you add FF. Well, FF is -1, so all you're doing is undoing this increment. You're adding 0 to the second byte. And then if there's no carry, then you're subtracting 1 from the second byte. Similarly, here in this case, if there's a carry, you are adding 0. You just jump to the end. And if there's no carry, you're decrementing from the second byte. So what I had was correct and equivalent. I wish I had come upon that like intentionally instead of kind of like fumbling my way towards it, but nevertheless, it is correct. It is possible that there is a tighter way to write this, but I'm not going to worry about that for now. Yeah, like you could do some things. No, never, doesn't matter. Like this bit operation takes 8 cycles. I could replace it with one of the rotate instructions to push the top bit off into the carry register, carry flag, and that would save 4 cycles. And also maybe a byte. Maybe I should do that. So I believe this should be equivalent if I just RLCA. That's going to push it into the top, and then replace this with a. So that's a little bit faster. Is there anything else that I could do? That's something obvious that just stuck out to me, but I think that's probably good. Let me just check to make sure that didn't break anything. Like plays the same. Yeah, this feels to be about the same. So we do have to add a speed cap. That's one thing. But before I go and add the speed cap, the other thing I need to do, this kills me. I was just giving some guy on Reddit a hard time because he was saying some stuff about the Game Boy. And I was like, no, listen to me. I've been programming the Game Boy for 20 years. Maybe not quite that long. I know everything there is to know about it. Let me school you. And then I was on the Discord, and the Game Boy Dev Discord, and someone like posted some code, and I noticed they were doing a thing that I didn't think was possible. I did not realize, or maybe I realized once and I forgot, that you can directly load a constant into the memory address pointed to by HL, instead of loading it into a register and then loading it into HL. It's like, it saves you 1 byte, it saves you 4 cycles, it saves you from trashing a register. And just like, somehow I didn't know that it was a thing. Or, yeah, if I knew it was a thing, I'd forgotten about it. And I've been doing that throughout this code base, which is super, super embarrassing. So I'm going to take a little bit of time to try to find anywhere that I'm doing that and replace it with the faster code. So I'm just looking for anywhere where I do, like here, right here. I load A with 128 and then I load it into HL. And apparently I can just do this. Or I can just do this. So, like, it's not a big deal, but it's just like, man, how did I miss that, you know? So, yeah, forgive me for taking just like a couple of a couple of minutes to take care of that. And I can't, unfortunately, I don't think, let me double check the sheet. I can't do that with the increment. Geez, I'm not even using XOR here. I should use XOR here. I can't do that with the increment mode. So for whatever it's worth, I might as well just do that. Take advantage of the increment, which does trash A, but whatever, the A register. See if there's anywhere else that I'm doing this. No, why would you search for that? It's fine. Yeah, here, another place. Another place? It's doing this all over. That's horrible. Like really, I'm looking for load HLAs. I mean, I might as well do it here. This replacing the load A or XOR A, load HLA with load HL0 doesn't actually save me any code, or sorry, doesn't save me any cycles or bytes. But this looks a little bit cleaner. It's a little bit more obvious what's going on, so I prefer it. Yeah, that's fine. That's fine. Like anywhere we are doing arithmetic on, like here we need to use that, but I saw a few other places where we might have been doing it. Game. I should really be looking for that. I believe I checked all these. Just sort of like that, like roughly lines up. There's that one. There's that one. And then there's that one. And those are all places where I need to do it. And that's in the macro where I needed to do it as well. So okay, next let me look for in game.asm. Yeah, same deal here. And like realistically, outside of the most performance sensitive sections of your code, shaving off a byte or a cycle here or there doesn't really make much of a difference, but like there's something to be said for good practice. And it's like it's easier to read, you know, like you don't it's direct. You don't have to say, well, why is he loading A? Did loading A change something later on, you know? So that was in game over. Now we're looking. I'm gonna go do title screen first because it's easy to check. Yep, same diff here. You know, actually, even though I don't think it makes much of a difference on the whole, saving a cycle here or there. Or a byte here or there. Every once in a while, you read these stories about game devs who are like really running up against the absolute limits of you know the ROM chips that they've got allocated for their game or whatever, and it really does. They really are like trying to shave off individual bytes. There, it's fine. So, you know, we might as well get ourselves to might as well do what we can to shave off bytes where we need to, or like while we can that are easy to shave off. go. I think that should do it. I think that was all of them. We're just down to like a few places where it actually makes sense to use the value in the register. Cool. Let me just rebuild. Let me make sure I haven't busted anything really obvious. ROM, run. I can't believe I didn't know this, you know? Cool. That seems good to me. And then we reload. Cool. So, I believe I added a line about it to myself, or note about it to myself in the to-do file. Although I never committed that, so yeah. Let me just sorry, I'm not going to save that. Not going to save that. Those changes look good. Those changes look good. Those changes look good. To me, to my eyes. Let's say like minor optimizations here. Some nice minor optimizations to start the day off. Like, how good is that? Most of them, I mean, it's not really great. It's like optimizations I should never have had to make in the first place because I just should have done the right thing from the get-go, but nevertheless. Okay. Minor optimizations. 41 deletions. Look at that. 41 deletions. So now I'm going to go back to that to-do list. I think really the big thing right now is to get... I can get rid of this because I did double check that it was doing what I want it to do. Now I need to add a speed cap. Which is going to suck again because it is... Yesterday we were doing 16-bit math. To 16-bit addition to speed the ball up, and now we're doing 16-bit comparisons. It's also unfortunate. So what I might do is I might just speed the ball up but then cap it. And I have to cap it in either direction. And I have to cap both X and Y. So I'm probably, again, going to use a macro for this just to keep, it's going to bloat the code a little bit, but it is going to make things easy because I don't need to worry about passing parameters and storing parameters and stuff. And as I've said repeatedly throughout these videos, if there's one place to use bad practices and write a bunch of macros, it's probably when you're doing like core collision detection math. Because math code is hard, especially when you have to like try to juggle stuff between registers and memory, and because collision detection code is slow and it's like really vital to get it fast for performance. So if there's one place to cheat, oh, and in VBlank as well, because VBlank is also super performance sensitive. Things like loop unrolling makes a lot of sense. But just let's do this right now. We're just going to focus on the positive direction, and we're just going to focus on, oh god, on ball velocity X. And it's really going to suck because we have to do signed 16-bit comparisons. Oh god. Okay. I mean, let's just get to it, right? So I'm going to start in the simplest possible way, which is pretending that it's always positive. And then just expand from there. Pretend that it's always positive. Only focus on capping the top. And only focus on ball velocity X. So let me actually note this down. To do cap negative numbers. To do, and I need to add a note to myself to also handle it. like handle signs this. Cap, yeah, okay. And the reason why I say I need to handle sign this is that if I don't, it's going to look at a speed of like 129, or sorry, 128. In an unsigned system is 128. It's greater than whatever we want our max speed to be. In a signed system, 128 is actually minus 128. And it's like far less than what we want it to be capped to. So so that's why I need a note for handle sign this and qdo handle ball velocity y. I'm actually going to do it in this order. So I'm going to start from there and just work my way out. Why is Visual Studio Code is so weird about indents? I do want to make sure the camera, at least every once in a while, captures my incredibly sweet shirt. We got Mario, we got Link, we got the AOL logo, we got the text, take care of yourself online, which I think is such good advice, in the style of the AOL logo. Yeah, always take care of yourself online. It's a dangerous place out here. Okay, let's do it. Enough talking. So, the first thing that we want to do is we want to look at ball velocity x plus 1. We want to look at the upper bite. You know, if I just focus on the upper bite, no, I still need to compare. I still need to, yeah, okay. Sorry, so I'm going to get that into A. And I'm going to say, well, is this less than 3? Right, let's say I want to cap it at 3, which I think is super, super reasonable. If it's less than 3, like if it's 2, say, 2 minus 3 is going to underflow. It's going to go below 0. The carry bit is going to be set. So if it's set, carry bit is set, I'm done. I know that I'm okay. If the carry bit is not set, then it is at least 3. So I want to I could probably optimize this a little bit by loading 3 into a register. Because then I could just write it right. Well, but then I couldn't do whatever. This is the danger. It's to get too caught up in micro optimization. And then I want to focus on the lower bit. I mean, I don't even need to do anything. I could just load it with 0, and I know that I'm good. If I'm capping it to 3, which is going to make for the easiest code, probably, that's what I'm going to do. So that's all I need to do to cap it for the sign. Or if I focus only on the positive direction, I focus only on the sign direction. Easy. Next, what do I need to do? Next, I want to focus on signness. So all I'm going to do there and here I can't do my rotate trick that I did earlier. Because I still need to use the value in A for this comparison. So what does that mean? So basically all I'm saying now is if it's negative, I know that I don't need to worry about it. I already know that it is certainly much less than my cap of 3, so I just skip it. And I should probably rename, well, it doesn't really matter, but I'm going to rename this just to keep this code as obvious as possible in my head. Yeah, and now here, instead of jumping to done, what I'm going to do is I'm going to jump to some block of code I'm going to call negative, which is going to go here. And here we're assuming, we know that it's negative, so we want to do kind of the reverse of what we were doing up here. So let me open up my calculator. So I want to cap it to -3, which is FFFD. So if the upper byte is any lower than FF, if it's like, I don't know, FE, if it's FE or something, like we know we're way below. We're way below where we want to be. And this is probably never actually going to happen, just because of the nature of like the capping. Like we're never going to end up at -256 because we're trying to cap at -3. So there's something to be said for, I don't even need to think about this. How does that make sense? Oh, yeah, actually, never mind. This could totally happen. I need to shut up. I forgot that I'm working with subpixels, and it's not really 3 that I'm looking for. It is like 300. So we're just going to do the opposite here. We're going to compare it to yeah, it's not -3, it is -300. Hex. So that is going to be FD0. So if it's ever any lower than FD, then we've done something wrong. So like, if it's FC, FC minus FD is going to trigger the carry flag. FD minus FD is not. FE, yeah, okay. So if the carry flag is triggered, then we have to do something here. I might even just be able to jump to done. I believe I can just jump to done here. I can probably do something much the same way. I'm just going to load FD into the register. I do want to check one thing. So -300 to FD. So suppose I add 1 to that. So, right, if I add 1, it's actually going slower. So yeah, the limit is 0. The limit is still 0, I believe. And then I think I'm just done. Now I'm just done. Okay. And then, so then what do I need to do? Now I need to handle ball velocity x. And to do that, I'm going to turn this into a macro as well. Much as I did for speed up. need to replace that with /1. I need to add the unique string identifier to my labels. Fingers crossed, this is all correct. And then all I need to do is speed cap ball velocity x, speed cap ball velocity y. So now I've like properly inlined all this code. Let's do it. Did it build? It did not build. I screwed something up somewhere. Line 80. Whoops, that is all. I, for the life of me, do not understand why sometimes... No matter. Never mind. Is it because of this? Maybe it's because of that. Or whatever. Whatever. No matter. Never mind. There we go. That built. Now let's see how well it works. Here's the real moment of truth. Oops. That felt speed cap to me. The problem is I cut my lives down super low to help debug. So let me crank those back up again. Starting lives, I'm going to set this to 4. 4 is a good number of starting lives. Because it'll definitely be easier to test this. Like if I've got cleared some balls. This still looks like it's going real fast. I hate to say it. That still looks like it's going real fast. Let me go to ball velocity x. Well, no, I mean that's speed cap to 3, and ball velocity y also speed capped. Well, also speed cap to 3. So that actually does seem correct. Maybe 3 is just really fast, which is probably fine. Like if it never goes faster than that, I think it accelerates a little too quickly, which I might want to tweak. But if it never goes faster than that, like I feel like that is like a good max speed for a breakout game. So the only thing I'd tweak is I would okay. I trust that that is correct. If it never goes faster than that, then that is a good max speed. I do just want to slow down the acceleration a little bit. So where do I have that acceleration? I have it defined here. I'm going to do that and see how that feels. Run. The other thing I need to do is I'm not resetting the ball's velocity, which I need to fix when you lose a life. But I feel good about this, so I'm gonna do it. Yeah, game. Absolutely. Like it's really starting to come together and is like turning into an actual game. It's awesome. I gotta keep that. I gotta keep that. These two get deleted. And let's save that and let's commit it. Add speed cap. I mean, it's not like it's the coolest game in the world or whatever. Like, if I had my druthers, I would be making, you know, something like stupid and ambitious, like a Metroidvania or something like that. But yeah, it's something. I'm like taking advantage of some time I have not working to do this. If I decided I was going to make something really ambitious, I would, you know, spend 2 years on it, and I can't go with it working for 2 years. Probably. Well, yeah, you should. I support your goal. Um, yeah, if what what's stopping you, if anything? Okay, let's go see. Yeah, yeah, I feel that. Day job is busy. It's I almost wish, being a programmer is like the one lucrative skill that I have. Um, and but I wish I didn't have to do it professionally because it just drains all the joy out of doing it as a hobby. Um, and I don't enjoy doing it professionally. Like being a professional programmer sucks, at least at every job I've ever done. And so it's like not only is it depriving me of like one of my favorite hobbies, it's also making me miserable every single day. But it's also hard to complain because right now being a programmer is such a good gig, right? Um, where? Yeah. God, you're an animator. Are you like a sort of a 2D like pencil and paper animator, or do you do like computer stuff? 'Cause I feel like, I feel like both are really hard and not, oh, both. Okay. Yeah. Like I would especially feel as though doing it with like pen and paper would just be like so miserable just because of, I don't know what I'm talking about. I'm not an animator, but you have to like draw so much, like so many frames. Like it would just be, uh, drive me crazy. But like, I don't know. Yeah, I think just like doing anything professionally sort of makes it less fun. Yeah, time consuming. I wish I were better at drawing stuff. I think that's such a cool skill to have. Um, like being good at art. So I wanted to do check bottom. When I was a kid, I really wanted to be a computer animator. That was my dream. Um, I had this book. I'm gonna go pull this out because I can. I had if it's like on hand. Yeah. When I was a kid, I had this book about like becoming a computer animator. It's like what I really wanted to do. I thought that computer graphics were just like the coolest thing. Like it was, I'm talking like early '90s or whatever. Um, and it was like Jurassic Park or whatever. And just whenever you saw computer graphics in a movie, it was like there's the future. It's so exciting and cool. Um, but I just don't have any artistic talent. So I don't know. And it's like it would be a uh, a real struggle to at this point in my life try to like really foster that and nurture that and probably go to school and get a degree and stuff. Yeah, I mean I kind of feel that way too, really. You're 28. I feel that way about talent too, kind of. Like at least something I like to believe that you can do anything if you put your mind to it. But it's also like, man, school's expensive. Taking all that time to learn stuff is expensive, and I don't know. I'm at like a real crossroads in my life in terms of figuring like how do I sustain myself for another 30, 40 years and like not go crazy. Yeah. Yeah, lean into your strengths, find a way to make it work. I guess. Yeah. What I really would love to do is just make Game Boy games, but I don't think I can really do that. Um, I mean, I have thought about trying to start a game studio. Um, so I believe what made me want to do a Game Boy game. I believe that some part of adulthood is about uh, doing all the things you wanted to do as a kid, and like now that you actually have the ability to do it. So let's see. Let me just. So, um, maybe I don't want to do it here. Maybe I should do this in Watch Ball, which is a thing. Um, so when I was a kid, I played the Game Boy. I loved Game Boy games. So I wanted to make a Game Boy game because that's what I wanted to do. And I've just never grown out of that. Um, yeah, hell yeah. And there's just something like powerfully nostalgic about the Game Boy aesthetic. I think it's like there's something kind of like dreamy about the black and white. Like memories kind of lose a lot of their colors. Um, and if that makes sense. And I think like when you think about the past, at least for me, because yeah, yeah, like I don't know if this has to do with like the particular generation I'm in or if this is like a universal thing. Like the past for me was stuff before my time. Stuff before my time was all analog. It was all um, uh, what do I have? I should have constants for this somewhere, probably. Um, Everything was analog, and the tapes had started to fade, and the color reproduction just on the cameras wasn't as good, and there was stuff in black and white, and so I somehow feel like the Game Boy kind of inadvertently taps into that. So yeah, okay, just start at like 1 for X and -1 for Y. So and so I feel like there's some sort of like I'm engaging in this sort of nostalgic activity, and there's a way that really fits. That like the nostalgic activity should produce something that is itself kind of very tied to memory and nostalgia. Um, my sorry, I feel like I just got like very kind of like philosophical there. My oh god, what is it? It's not FF01. It's an unsigned number. It is FF00. Okay. Yeah, I'm 32. Just so bizarre. um, how do, it's different. um, it's I think it's the right way to program a Game Boy game. Um, like C is just too slow, and it's like just if you want to make anything interesting, like it's going to be a real bottleneck. And there's something to be said for like you can't really you find other ways to sort of distract yourself, but As a programmer, I do find one of the problems in programming in high-level languages is you end up getting like caught up in building lots of abstractions, um, and you just can't do that in assembly language. And there's a way that like the super limited resources makes it kind of like a fun little like logic puzzle. Oh no. It's really funny. I'm making this breakout game, and I'm actually really, really bad at breakout. Okay, but that did work. Cool. Um, so I kind of enjoy it in its way. Sometimes I actually like really prefer it to something like using Unity, which I've never done anything really like big in, but I've played with it because it's it's like the thing that everyone uses these days for making games. But there's a way that there's so much magic in Unity. Like, you know, lots of people don't even write any of their code at all, and I'm like sort of really like I want to understand everything that's going on. And you just can't do that in Unity because it's so complicated. And here you have to understand everything that is going on, like to you know, I think a really good model when programming is like you should always kind of try to understand everything at like one abstraction lower than whatever it is that you're doing. So like if you're programming in C, maybe you're not thinking in assembly all the time, but you should kind of have a rough understanding of like what kind of assembly code is generated. And if you're programming in a higher level language, maybe you're not like actually thinking about um, the sort of machine level of how the um, interpreter or whatever is running, but uh, you should have some idea of it anyways. Down to the registers. Well, I actually, you know, I don't think that C, the jump between C and assembly is as big as a lot of people make it out to be. Especially not on the Game Boy, because on the Game Boy you're like you can't just use normal C on the Game Boy and expect things to be okay. Um, because you have to be kind of conscious of the fact that like, oh, this structure access is going to be really, really slow, or you know, iterating over an array without using an index variable instead of incrementing a pointer is going to be really, really slow. I don't know how well or even like passing a bunch of arguments into a function is going to be really, really slow compared to using global variables. Um, so the only real difference is like you do need to sort of think about the only time C really I think would help a lot is when you're trying to do math, which I've had to do over the past couple of days, and has been miserable. But 99% of the rest of the time, you know, it is really just like it's not that different. Instead of saying ball state equals ball moving, I say load accumulator with ball moving, load that into ball state or whatever. I don't think it's really that bad, but I do think learning C first is actually a really good stepping stone because you will get like an idea of how pointers work and stuff like that. And you know just have an idea of like how a CPU kind of works. Like it's this thing like when you're programming in C, you know, if you're a good C programmer, you do like understand like this is how the stack works. This is how registers and stuff work. This is how pointers work. You're just not thinking about it all the time. Yeah, no worries. So what's the next thing that I wanted to do? Yeah, that's your girlfriend is way more important than anything I'm doing. For sure. Right, okay. So the one last thing I wanted to do, I was gunning to get done before like the next alpha release. This is actually going a lot faster than I thought it was going to go, so maybe we can squeeze in a little bit more for alpha 2. I wanted to get alpha 2 released on Monday, so we got a little bit of extra time. We can do a little bit more probably. So the thing I wanted to do was, do I don't have a copy of that book, unfortunately. What I wanted to do was, when the ball collides with the paddle, here, when the ball collides with the paddle, if the paddle's moving, yeah, if the paddle's moving, add a little bit of extra force in the x direction corresponding to the paddle direction. Okay, so the paddle direction is going to be stored in this paddle velocity x. All I want to do is, what is the paddle velocity? The paddle velocity x is going to be something like, um, 180 if you're moving. Okay, yeah, cool. So I'm just going to shift the paddle velocity x right by 4 bits, and then I'm going to just add that to the ball velocity after the reflection, so that, yeah. Actually, the reflection is not going to affect it, but I am going to do it. Yeah, okay. It doesn't. I'm going to do it before the speed up, so that I implicitly get the speed cap. So I don't even need to think about that. So I'm actually just going to spin. This should be pretty easy. I'm hoping. The only nasty thing is we do have to do a 16-bit shift. But even that's not too bad. Load HL with paddle velocity x. Because what I do is, it's 4 bits, so I just take to do the 4-bit shift, all I do is I swap it. And then the swap will swap the nibbles, so the top nibble ends up in the bottom nibble. Then I'm going to AND out the top nibble. And I'm going to load that into B. And then I'm going to get the top nibble, or the top byte, and I'm going to swap it again. This time I AND out the bottom, and then I OR it with B to get the actual amount of spin I want to add. This might be excessive. This power of spin here might be too powerful, but we'll see. And then I'm going to add it to the ball velocity. we just do that, and then I just add it to the ball velocity. I return if there's no carry. If there is carry, I'll implement my return. Okay. Bits. Maybe comment that a little more thoroughly. But there we go. So let's see how well this works. Unknown simple paddle velocity, because I probably just didn't export it, which I'm going to do. There we go. How do you create graphics in assembly? So there's, I mean, let me be clear. To create the graphics, you can just do something like, let me see if I can find that file. Yeah, here we go. You can actually just define it as constants like this, which is probably not the best way to do it. The best way to do it, for any sort of like fancy art, the best way to do it is to create a ping file and then feed it into a conversion program. So the assembler that I use actually comes with a conversion program called RGB GFX. Yeah, I don't actually want to display it. It comes with a program called RGB GFX. So you can just use that. You feed your ping file into it. It's going to spit out a binary file, which I have here called font.gfx. And then you just, where do I include that? I include that somewhere. Tiles. I include it in tiles. No? Sorry, one sec. Oh yeah, I included in font.asm over here. Yeah, so I include it. And that actually puts the graphics into the ROM. And then the next thing that you have to do is you need to actually run a procedure to copy the graphics from the ROM into video memory. And that's what I do here in this load font routine. And then the only other thing there is you need to make sure to do that. You need to make sure to do that during VBlank or when the screen's off. Because when the screen is being drawn, video memory is locked. The CPU can't access it. You need to make sure the palette is configured correctly. And then once your tiles are in video memory, you just lay them out in the map. So yeah, you can see this is where I loaded that font into video memory. I set up my palette. That's actually, I think, just right here. You set up the palette by writing to a register, and then you use the map to specify which tile goes where. Does that answer every possible question you might have had about it, or did it just add a bunch more questions? I'm going to lower my volume slightly. So, yeah, I just got an implemented spin. Spin was working. Cool. I don't know if it was working, but it was building. Let me test that. So right now, everything just works as it should, but I'm not really noticing much spin, which could just be because it's a little too subtle, or it could be because I'm doing something wrong. Either is possible. Let me go here and go to add spin. I think I called it procedure. Now let me just step through it to make sure it's like doing the right thing, but just not fast enough. So right now, it should be adding nothing. Oh yeah, there is a bug. I need to load this back into A, I think. Yeah. Run. Reload ROM. Run. Oops. it still feels like if there is any spin being, oh yeah, actually there was a lot of spin there. Like it felt right to me, but no, this still feels a little too subtle. And I keep getting a game over before I can really properly test it. Ah, terrible. Run. So I believe that my paddle was moving there a little bit. Let me go to... Yeah, it was moving a tiny little bit. Actually, quite a bit. So yeah, the lower bit, 0, that's fine. Load A, swap A, hand it out, or it with B. Oh, shoot, yeah, there's another bug there. I'm not doing the right thing again. Yeah, I got this backwards. I want to and out that. I want to keep that. Geez, super simple. I can't even claim that I haven't had my coffee today. I have had my coffee today. And I can't complain that it's because this is hard, because it's not. This is like bread and whoops. Did not want to actually have the break point there. This is like assembly programming bread and butter. So nope. I'm still not really feeling the spin. So once again, let me check this out. Let me hit run. Okay. So there, the paddle is moving. Swap A, and it, or it with B, load A, B. Oh wait, shoot, I screwed it up. But how do you draw shapes? You don't manipulate individual pixels. I mean, yeah, not really. So the Game Boy's screen is drawn using, at least backgrounds. The Game Boy screen has effectively 2 layers. You've got backgrounds, which are done via tiles, and then you have sprites. So starting with the backgrounds, what it is you've got this map, which is this array of bytes in memory, which is 16 by 16. Is that right? Yeah, 16 by 16. 32 by 32. It is 32 by 32. And you set each byte to be a particular tile. So let me go back to the, let me go get a game over, or reset. Let me reset. So here's my title screen. And let me open up the video memory viewer. So this, you can see the address in memory over on the right over here. If you look at that, like here, it is 9821. That just means that in memory at address 9821, you can see that it says tile number 8B, which is at address 88B0. And if we look over here in the tiles at address 88B0, where are you? Yeah, here we go. Tile number 8B at address 88B0 is this B tile. So that causes it to draw this B here. There aren't enough tiles to completely cover the screen on the Game Boy, so you can't really draw individual pixels if you want a full screen image. Some games use like X in particular. Let me actually, no, I probably shouldn't get distracted enough to load up X. There's some game, any game that tries to do like actual individual pixel manipulation will use like a restricted viewpoint and just use one tile for each location. At least that's probably the best way to do it. But even that's really, really hard because these tiles aren't like stored as like individual pixels that you can like write to. The graphics format on the Game Boy is, I don't know if there's like a good explanation of how it's done here that's like really clear. They are 2 bits per pixel and they're stored in a bit plane format. So the actual format of it is it'll store 1 byte, and that byte is going to be one of the bits for the top row of the tile. There's no good way to get it to stay put, so I can't point at it. So this tile in memory. Let me go actually pull up this tile in memory. So that's at 88F0. So this tile in memory is going to be you can see it's 7C, 7C. And if we go look at what, yeah, no worries. If we go look at what 7C is in binary, 7C is over here, 0, 1, 1, 1, 1, 1, 0, 0. And that actually corresponds to which pixels are black. And you can't see this because all of my tiles are in this font are either black or white. But so that is storing the first bit of each pixel in 7C, in this first 7C. And then in the next 7C, it is storing the second bit of each pixel in that row. And then you repeat for the row after that. It's 80, 80. So 80 is going to be, let me actually just type that in. You can see it's just the first bit that's set. And that corresponds to giving you this first pixel being black, the first pixel being 1, 1. So long story short, don't try to draw your graphics pixel by pixel. Use a conversion program. Draw your tiles in Photoshop or Paint or whatever you want, AE Sprite. Use a conversion program. Load it into memory, and then lay out your maps like this. And this is true basically no matter what kind of game you're making. And then there's also sprites, but sprites do a similar thing. Sprites have a tile. A sprite is an 8-byte tile that you can like position independently of the background by setting these X and Y locations in a special kind of memory called OAM. Yeah, and yeah, here we go. This is where in the Pandocs it gives you tile data information. So byte 0 is the first line, byte 1 and 2. Yeah, it's and there's a more visual explanation here. So yeah, I would say if you understood some but not all of what I said, I would say the best thing to do is to go open up the Pandocs, read this, and maybe go look at this link and read this as well. And I was trying to figure out whether my spin code was working, so I don't actually want to load. Do that. That's better. Run. Okay. Let me run again. That did seem to do something for the spin. It actually seemed a little too extreme or off this time. Let me see how that feels. Let me go back to that breakpoint and disable it. Whoops. I'm so bad at my own game. I think at this point, though, it is. Yeah, I did bounce it once off of this paddle. So that's in that book, right? There's like the ebook called this library called Gingerbread. I have never used that. I can't vouch for it. It's probably good. Or at least a good way to get started. Especially if you're like working through a book with it, like. So I had spin. Wow, that's so extreme. And did that even, like, that definitely didn't feel right, even if it was the code that I wanted it to be. I'm wondering if I should, like, just shift it right once more, just. Speed of the paddle is too slow. So I have it so that if you're just moving left and right without pressing a button, it goes slowly, and then if you press down A, it goes. I'd say that's pretty fast. I'm not sure if I want to make it a whole lot faster than that. And one thing to remember is that this is an emulator. Does this actually have the option for motion blur? I think it might. Graphics, mix current and last frame. Let's see how this looks. Well, even this isn't that extreme. Like on the Game Boy screen, if you've got something moving around an awful lot faster than this, you're just not going to be able to make heads or tails of it. It's just going to be a big smeary blur. At some point, I need to pull out my Game Boy and demonstrate that. But I don't know. I attribute how incredibly annoyingly difficult this is to the fact that right now there's just too many tiles down at the bottom, which doesn't give you a ton of space. Also, the fact that I'm really bad at it. There's also, I'm starting to see like the limits of, I took a really ad hoc approach to collision detection, a cavalier approach to collision detection, where I just used the center of the ball. And I think that's like really starting to bite me. You can see places where the ball is just kind of ripping through blocks in a way that doesn't feel right. So I should go back to that at some point. Have I done other projects for the Game Boy? Nothing that has ever been widely released. I've got a few various half-finished projects. I tried to make an RPG. That was my first big thing. That was about 10 years ago, and that was kind of a disaster. I tried to make, and this is something I've got on sort of like the back burner that I want to come back to, is I tried to make a like a Metroidvania style game. That's sort of like the real dream project. But the problem with those always is like I'm working and then like eventually I sort of like stop working on it daily, and then I try coming back to it and I like lose track of where I was, or I just end up losing motivation. So I feel like this is okay though. I'm gonna call this the spin that I wanted to add and be done with it for now. I might come back and might tweak it. improve collision detection. So that's one of the reasons I wanted to do like this kind of really simple sort of game, because it's like a good way that I can like really make sure that I get something done. And like I can come out of it at the end of my brief sabbatical by being, look, I made a Game Boy game, I finished it. It's cool, and like actually have a thing done. Sorry, get diff. Yeah, I just want to revert that. I don't know how I get that white space change done. Put in. So how long have I been streaming? I'm at 1 hour and 15 minutes, which is a good. I think a good time for me to call it, because I got done the things that I really wanted to get done. Except, let's put a question mark there. Not super important to me. As a 100% thing, git push. So I think I'm gonna call it for the day. Absolutely, I do this. I'm trying to do this every weekday at 2 p.m. Pacific. So please, come on, tune in, and say hi. And I'm like super happy to talk about this stuff. And then also, I don't know if you're on the Game Boy Dev Discord, but that is, I try to be on there much of the day. You can just get to that from gbdev.io. Okay, cool. Yeah, I'm on there. I'm like super happy to answer questions on there whenever I'm around. And so that's also like a good place to talk about stuff. So cool. Thank you so much for tuning in. I had a couple of you. I think I had 3 viewers at the peak, which is awesome. I think that's the best I've done so far. So thank you so much. And yeah, I'll be back tomorrow. Take it easy.